Hi guys, it's me, Mr. Bertoch, your incredibly cold science teacher. Seriously, it's really cold in here. My wife likes to freeze me, but anyway. In this video, we're going to be learning about how environments change over time. Environments are made up of all of the living things as well as all of the non-living things that are there together. And we call those things factors. So there are living factors and there are non-living factors. And scientists like to complicate things and make them a little bit more difficult to understand than is necessary by using big vocabulary words. So I'm going to teach you a couple of these big vocabulary words. Okay, the first one is biotic. Biotic. Biotic means living. B-I-O, bio means life. Anytime you see B-I-O on something, it's probably talking about not B-O, because that's totally different. That's body odor. That means you smell, but I'm sure you don't. But B-I-O, bio, means life. So biology is a study of life, right? So biotic is going to be a living thing or a once living thing or something that comes from a living thing. Biotic factors or living things in an environment. Okay, and then abiotic, the letter A is kind of a way of saying not or opposite of. So abiotic means non-living, never living. Biotic factors in an environment would be all of the things that are alive or were once alive or came from something that's live. Like, for example, a bear is a living thing, obviously. So a bear is a biotic factor in an environment. A dead bear, not a living thing, he's dead, but he's still a biotic factor because he was once living. And bear droppings, which have never been alive, but they come from a living thing. So bear droppings are also biotic. Okay, well, what are some examples of things in an environment that are abiotic? Remember, big fancy sciencey word, abiotic factor, which just means non-living things. Anything in the environment that's non-living is an abiotic factor, like a rock and dirt and air and temperature. Temperature is a factor. It's in an environment, right? One that is often very confusing to students is water. Is it biotic or is it abiotic? Okay, a lot of students will say that water, or they'll think that water is biotic because living things need water. But actually, water is abiotic because water itself is not alive. Water has never been alive and doesn't come from a living thing. So it's an abiotic factor in an environment. Yes, living things need water, but they also need sunlight, right? They need a lot of things that are abiotic factors. So an environment is made up of a lot of different biotic and abiotic factors. And these biotic and abiotic factors create what we call equilibrium, a state of equilibrium. Remember, I talked about big fancy sciencey words. I know, I'm sorry. Scientists like to use fancy words to impress people at dinner parties. They're like, equilibrium. And all the guests of the dinner party are like, wow, you are smart. You know big words. So what does equilibrium mean? Equilibrium means that everything is in balance. All of those factors, all of the biotic and abiotic factors are in equilibrium. They are in balance together. So the rocks and the temperature and the amount of water and the amount of sunlight and the various animal species, all of these things are staying more or less the same year after year after year. So if I go into a forest, I'm going to find the same, more or less, no matter when I go. I mean, it might change by season, but at the same time of year, if I go to the forest and today, and I go there 5 years from now, and I go there 10 years from now on the same date, is probably going to be very similar each of my visits. Roughly the same amount of trees, roughly the same temperature, more or less, similar numbers of the different species of animals. So it's in equilibrium. Sometimes an environment will change, and it changes when something in that environment is out of equilibrium. Something changes, and it can be a lot of different things that change. Maybe the temperature changes, and maybe it's the amount of rainfall that changes. So if the temperature changes, well, that's going to impact the rest of the environment, because the rest of the environment, the animals have adapted to a certain temperature, the plants have adapted to a certain temperature. Everything is used to, it was in balance, it was in equilibrium with that temperature. When the temperature changes, then everything is thrown out of balance and has to adapt all over again. If it's the amount of rainfall, maybe there was a lot of rain, and then over many hundreds of thousands and millions of years, a mountain slowly builds up, and that changes the area so that now it doesn't get the rain anymore that it used to get. Well, you're throwing the rainfall out of balance, out of equilibrium. And so that area that used to get a lot of rain, well, now that it's not going to be enough rain to support the life that was there. And so the environment is going to change until what? When will it stop changing? Whenever it gets to equilibrium again, right? And eventually it will reach equilibrium again. Everything will get into balance again. And maybe what was a forest will now be a desert, but it will be in balance again. And then it will stay in equilibrium. It will stay in balance for many thousands or tens of thousands or hundreds of thousands or even millions of years, until something else throws it out of equilibrium. Something changes, and it causes all of the other factors, the biotic and abiotic factors, have to adjust so that they all come into equilibrium again. So environments are constantly changing. Where you live right now, if you look out your window, unless you're outside while you're watching this, then just look around. That, whether you live in a forest or a desert or a tundra or grasslands or prairies, which are a type of grassland, or wherever you live, it hasn't always been that area where you live. I guarantee in the past, at some point, it was different. Maybe there was, such as was the case in the western United States, there was a giant, vast ocean that covered the western United States for millions of years. Maybe where you live now is a desert, but it used to be a forest. Or it's now there's mountains, but it used to not be mountains, whatever. But your area where you live has gone through these periods where you've had one environment in equilibrium, and then something changed to throw it out of equilibrium. And so all the other factors had to adapt until they were in equilibrium again, creating a new environment. And probably multiple times that's happened. And these changes create layers that we call strata in the rock. As we look at layers of rock in the sedimentary rock, we can see different colors. Have you ever noticed that? As you drive along the road and you come across rocks that are cut out to make way for the road, and you look at the side and you can see layers. What are all those different layers? What caused those layers? Why are there layers in the rock? Well, each one of those layers represents a different era, a different environment in your area. If you have desert, it creates a very different color of rock that forms than when you have forests or when you have seas or whatever. So those layers of rock tell a story. They're full of the fossils of the things that lived in the area at the time. They're full of the type of soil. That's what's giving its coloration, right? The types of things that were being deposited there. So we can look through the layers of rock and read it like a history book and see the history of each time the environment where you live has gone out of equilibrium because of a change in temperature or rainfall or because of the formation of mountains or whatever. And we can see how the environment has changed time and time again. And every time you drive and you see those layers of rock, you can think to yourself, wow, I can count the layers of rock and I can see each time the environment, something has caused the environment to go out of equilibrium and to change into a new type of environment. So if you count the layers, and there's like 15 layers there, then you can say that this area has at least experienced 15 different periods where there's been different types of environments here. Probably more, because you're not seeing all of the layers. Some of them are still underground. You're just seeing the layers that have been exposed. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, well, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up, subscribe to the channel, and I release lots of videos. Also, in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos and they're much more targeted, and those ones are scripted, so you don't have to hear me like you are right now going blah blah blah. The end. Subscribe. Thank you. Goodbye.